Replication. Replication is a process of copying and maintaining the same data across multiple databases or servers to ensure data availability, fault tolerance, and scalability. It enables multiple copies of the same data to be stored across different nodes or locations, providing redundancy and improving system reliability. In a replication, data is typically written to a primary server or node and then copied or replicated to one or more secondary servers or nodes. This ensures that if the primary server fails or is overloaded, the secondary servers can take over, can take over, providing continuous data availability and faster read access. There is multiple types, or there are multiple types of replication, and the most famous of them is the master-slave replication. So, in this type, we will have a master database, and we will have, let's say, we have two slaves. We have slave one and slave two. So, in this setup, one server acts as a master, handling all write operations. So if we have a server, for example, which is doing requests to which is sending write or read operation to the databases, all write requests will go to the master. So this is write requests. And the master replicates this data when the server sends a request, like creating a new record, editing a specific record, or deleting any one. The master will handle all the write requests, and then the master will replicate all the data that been written. It will replicate it to the slave. Replicate. Okay. And the slave one and slave two, they only serves read operations. So when the server needs to write a specific resource, it will send a read request to one of the slaves. So the descriptions again, the master serves the write operations and then it will replicate the records that been created or edited or deleted to the slaves, and the slaves serve the read operations. So they when the server need to read a record, it will access the slaves, not the master. The common use case, like it's a common in read-heavy applications where the system requires high availability for reads, but writes are centralized. An example for that, a web application where the master handles user transactions and the slaves are used for read operations like fetching data for users, for example. There is another uh, another uh, another type of replication, which is master replication or active replication. So in this one, we will have master 2, for example, and this one, let's see, master 3, or I can just delete this master as well, so it will be easier to describe everything here. Master 1. So let me delete everything and go back. So in this configuration, two or more servers or masters are capable of both reading and writing. Data is replicated between all master servers, allowing multiple nodes to handle both read and write operation simultaneously. So the server can send write request to the master, and when the server send the write request to the master one, the master should give this should replicate from 1 to 2. So should replicate the data that been written to it to master 2, and also the server can send read or write operations, write and read. And if we got a write operation to master 2, the master 2 will replicate all the data that come from 2 to 1. So in this one, as we said before, in this configurations, two or more servers, which are the master, are capable of both reading and writing. Data is replicated between all master servers, allowing multiple nodes to handle both read and write operations simultaneously. The use case for this one, it's suitable for geographically distributed applications or systems where high availability is crucial and the workload must be spread across multiple locations. An example for that, like a multi-region e-commerce platforms where transactions need to be processed in multiple data centers while ensuring consistency across all nodes. Number 3, there is synchronous replication. Let's delete everything here. Let's assume we still have master 1 and master 2 and delete everything. So in synchronous replication, data is written to both primary and secondary. Let's have a primary and secondary databases. And if there is any write request, it will be written to both of them, primary and secondary. Okay. And the primary server here needs to wait for acknowledgement from the secondary servers before committing the transaction, ensuring that both servers have the same data at all the time. So when the server trying to make a write request, okay, it will send it to the primary and the secondary, and the secondary needs to get any acknowledgement of that process being success and it's being done. And when the primary get the acknowledgement, it will process this transactions, it will commit this transaction. A use case for this one, it's used in systems requiring strong consistency and minimal risk of data loss, such as financial applications, for example, like banking systems, where transactions data must be replicated to ensure real-time consistency between databases. Number 4, there is number 4. It's asynchronous replication. So in asynchronous replication, the primary server writes the data and immediately acknowledges the write to the client. The data is then replicated to the secondary servers at a later time, allowing for higher performance at the expense of potential data lag between servers. The use case for this, it's it's like the master slave also has the same thing. So we send the write request here, okay, and it will send an acknowledgement it's been created, and later it will be replicated to the secondary. It's ideal for applications where performance is critical and slight delays in replications are acceptable. It's a like example of that, like content delivery systems or logging systems where the latest data is not immediately required by all users. There are other, I would say other types of replication like core and paste replication and full replication, but this will go beyond the videos, the purpose of the video, because we need to talk about some basics, and we might create in the future dedicated videos about current based replication, full replication, partial replication, and asynchronous replication, and everything about that. And we need right now to talk about the advantages of the. Oh no, this is too big. The advantages of replication. The first thing, I don't know if you can see or not, but it's a pretty obvious, which is high availability. Replications ensure that data is available even if the primary servers fails, as secondary servers can take over operations. This improves system reliability and minimize downtime. Number two, which is fault tolerance. So by having multiple copies of data across different servers, the system can continue functioning even in the event of hardware failure, data corruption, or network issues. Number three, load balancing. Replication allows read queries to be distributed across multiple replicas, reducing the load on the primary server and improving overall systems performance. Read heavy applications benefit from spreading the workload across replicas. Number four, disaster recovery. So replications enables disaster recovery by maintaining data copies across geographically distant locations in case of catastrophe failure or disaster in one region. The data is still accessible from other regions. And lastly, data redundancy. Replications create multiple copies of the data, ensure that if one replica is compromised or corrupted, other replicas can still provide accurate and consistent data. There are some challenges come with replications as well, like data consistency, network latency, conflict resolution, and complex in flavor. And we create a dedicated video for the challenges of the replications. Um, okay, so we need to talk like I guess we yeah I guess we at the end of the video, because yeah we I guess we makes the 10 minutes already. So in conclusion, replication is fundamental strategy for improving data availability, fault tolerance, and scalability in distributed systems. It provides redundancy, ensuring that data remains accessible even in the event of failure or disaster. However, implementing replications require careful consideration of consistency, latency, and operation complexity. By selecting the appropriate application model like master slave, master master, synchronization or asynchronization or asynchronous, organizations can ensure their systems are resilient, scalable, and efficient while meeting the specific needs of their applications. So that's it for this video, and see you in the future.